Hello, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at advanced ionic bonding. So don't be intimidated by the title. It's still the same two rules for ionic bonding that we learned in the last chemquest with just a few more rules. Or just, we're adding a new trick, polyatomic ions. So if you remember, guys, from the last chemquest, question 10, we learned that the two rules we need to follow for ionic bonds are the positive ion must come first in an ionic compound, and that ionic compounds must be neutral. So we still will be using these two rules found in the previous chemquest throughout this one. So guys, now on to polyatomic ions. So polyatomic means many atoms. So therefore, a polyatomic ion is an ion that's made up of more than one atom. So remember, guys, we learned in the last one that subscripts tell us how many of each atom that chemical contains. So for example, we have a polyatomic ion, sulfate. Sulfate is SO4 with a -2 charge. In sulfate, there is always one sulfur, 4 oxygens, and it always has a -2 charge. That will never change. So down below, you'll find a list of several important polyatomic ions that we'll use throughout this chemquest. So first we have some polyatomic ions that end in 8. So this section will be helpful when you're thinking about question 1. Question 1 is asking us, what do all of the polyatomic ions that have the suffix 8? So remember, 8 is what comes at the end. So you'll see acetate, carbon 8, chlorate. 8 comes at the end, so it's a suffix. So when you're thinking about this, what do you notice about all of these polyatomic ions? What do they all have in common? So look at the chemical formula. What atom is contained in all of them? So question 2 is now taking what we used in question 1. So what two atoms do you think make the polyatomic ion silicate? So we know we can break this up into two parts of the word. So let me just move that cursor. So we can break up it into silic and 8. We know that everything with 8 contains what? What's similar. And then if we break up the element silic, what does that sound? What element do you think that is? Use your periodic table to try to figure it out. So next, question 3 is focusing on language. So the difference between calcium nitride and calcium nitrate. So think about, what does 8 mean? What did we just learn in question 1? And then what did we learn about ide from the ionic bonding chemquest? Specifically up over here in this first section. What did we learn about the endings of ide? Next, we can move on to the next section. So now we are going to start writing some formulas with polyatomic ions. So we are still going to use the crisscross method. Just this time when we crisscross, we're going to be using polyatomic ions. So we'll have a little bit more complex formulas when we are done. It is worth mentioning, again, that you can never change the formula for a polyatomic ion. Sulfate is always SO4 with a -2 charge. You can never have another form of sulfate. So guys, when we look at this, we're just doing the crisscross method again. So we put our positive ion on the left, we put our polyatomic ion on the right. We include the charges. So your polyatomic ions, you're just going to have to look them up. All of the charges are included. Then next, we crisscross. So we bring the 2 down to the right of the sodium, we bring the 1 to the right of sulfate. So this next part, when we're talking about parentheses. So parentheses are not super important in this problem because remember, we don't write ones. So we don't have to include parentheses because if we include parentheses, it doesn't change the answer. So what I mean when I say if we included the 1, we would need parentheses is because look, if we write the 1 here without parentheses, it looks like we have 41 oxygens, but we know that's not the case. We know we have 1 sulfate, not 41 oxygens, so the 1 would go on the outside of the parentheses. Then, parentheses in chemistry and chemical formulas are just like parentheses in math. We need to distribute this number, this 1, inside the parentheses. So we distribute the 1 to the 4. We distribute the 1 to the 1 that's written there. And remember, just like in math, we multiply by 1. So this tells us there is 1 sulfate and 4 oxygens. So it might seem a little redundant, but the next one will make a little bit more sense on why we have to use parentheses. So the next example, we have magnesium nitrate. So we start by writing magnesium, we start by writing nitrate. We then include the charges in the top right corner. Next we crisscross. We bring the positive 2 to the right side of nitrate. We bring the 1, the negative 1, to the right side of magnesium. So in this case, you need parentheses. There's no way around it, because this 2 is going to the right side of nitrate. If you didn't write that 2 there, MgNO3 with a 2, it would look like we have 32 oxygens. But in the cases, we don't. We don't have that many. So we use the parentheses to say we have 2 nitrates. So now you can see how adding the parentheses changes this problem. Likewise, now we can distribute just like we did up top if we want to. So this 2 can go here, and then it can also go to the 1 that's between the N and the O. Just like before, we multiply. So what this is telling us is we have 2 nitrogens and 6 oxygens. Down below, there are a few more examples of some polyatomic ions. So this example right here, potassium acetate. So I started the same way. I wrote potassium, I wrote acetate with the charges in the top right corner. Now we crisscross. We bring the 1 over there, and then the negative 1 to the other side. Remember, because they're 1s, we don't have to write them or use parentheses. So this would become KC2H3O2. Oh, we don't want to upgrade right now. We'll postpone. Then the next example, nitrate, magnesium nitrate. So we did the same. We started off the same way. We wrote the ion, the symbol, and the charge. Then we would crisscross. We'd bring this 2 over here, this 2 right there. So this would become magnesium nitrate with NO3. And then remember, so when you ask yourself if you need parentheses, so ask yourself, if you write the 2 here, does it say the same thing? Right now this says 1 magnesium, 1 nitrogen, 32 oxygens. Remember, we need these parentheses because we don't have 32 oxygens. If we distribute, we would have 6. So remember, very different, but remember, use parentheses when appropriate. So next, we have a few problems. So this first problem, the expression, we're trying to figure out how many nitrogen atoms are present. So we know that there's 1 magnesium. Then we would need to figure out how many carbons and how many nitrogens we have. So remember, when nothing's written, we assume that they're 1. And now we can distribute our 2. So we would distribute the 2 to the nitrogen. We would distribute the 2 to the carbon. Just like math, we multiply by 2. So then we would look. 1 times 2 gives us 2 nitrogen atoms. So next, you can do the same thing for 5. Questions 6 and 7 are also thinking about the parentheses. Why do we need parentheses in those examples? So think back to what we wrote over here when we were talking about the parentheses. Question 8. So question 8 wants us to name a few of these compounds. They all include at least 1 polyatomic ion. So remember, guys, we need to follow the naming rules that are still found over here with ionic bonding. So remember, if it's a positive ion, it retains the same name as the parent, so we don't have to change it. If it's a negative ion, we change the ending to "ide" by chopping off the last syllable. So we are going to apply these rules. So when we're naming this, we need to ask ourselves, is sodium positive? So we bring out our periodic table. When you bring out your periodic table, you would notice that sodium is right here. So that means sodium is going to lose 1 electron to look like neon. So if you lose an electron, it's going to become positive. So that means we do not change the name. It stays sodium. Then we need to be able to identify our polyatomic ions. So we look at our list. Is PO4 a polyatomic ion? So we come over here. PO4. Right there, PO4. Phosphate. So then we just name it phosphate. So the name of this is sodium phosphate. Next we need to look at part B. So again, we need to be able to identify our polyatomic ions if they're present. So let's take a look at NH4. Is NH4 a polyatomic ion? Yeah, it's right here, ammonium. So we know the first part of this is called ammonium. And then we need to look up the last part, SO4. You may remember that we've been talking about it already a few times. It's called sulfate. But we look right here and we see it's SO4 sulfate. So we combine the two. Ammonium sulfate. Alright guys, so work on the next four. Use similar. Remember, if it's a polyatomic ion, all you have to do, look up the name. So next question 9. Question 9 is now writing some formulas for the following ionic compounds. Remember, each of them include a polyatomic. So these are really similar to the examples we did right here. However, I will do one more before I ask you guys to do B through F. So we start with lithium phosphate. So we know lithium has the symbol Li. And then what we need to do is find the charge of lithium. Lithium's right here. So it's much easier to lose one electron to look like helium than to gain all of these electrons to look like neon over here. So we know we're going to lose one. If you take one away, it becomes a positive 1. Next, phosphate ends in 8, so we know it's a polyatomic ion. So we look up phosphate on our list, PO4 with a -3 charge. And now, the next step is to crisscross. So we would write Li3PO4. Remember guys, the 1 that's being carried over from the lithium, you don't need to write it because it's a 1. We always assume whenever nothing's written, it's a 1. Likewise, if you do want to write it, you would need parentheses. So you are welcome to write the 1 if it helps you, but make sure you include parentheses, otherwise it's going to look like you have 41 oxygens. So now answer B through F. Question 10 is another formulas question. It's just highlighting the difference between "ide" and "ate." Remember, if it ends in "ate," it's going to have a polyatomic ion. If it ends in "ide," it's going to just be a negative ion from the PTE. And now the last page, guys, is we have a little bit of information about acids. So acids are still ionic compounds. We are still talking about ionic compounds, so that means the positive ion will be first, and that they will balance out and bond so that they are neutral. So acids, they are all compounds that contain positive hydrogen ions, H+, bound to a negative ion. So I didn't want to highlight that one because I had a few things written over here, so I did highlight the bottom hydrogen. Hydrogen always has a positive 1 charge. And then one more acid that I added to your list that's talked about in question 11 is carbonic acid. Carbonic acid has the formula H2CO3. So what we need to think about is, why do carbonic acid and sulfuric acid require 2 hydrogen ions, but hydrochloric and nitric acid only require 1? So to figure this out, we need to look at the charges. So we know that carbonic acid is a hydrogen bound to carbonate. We can look up carbonate on our list and see that carbonate has a -2 charge. We do the same thing for sulfur. It's a sulfuric acid, sorry. It's a hydrogens bound to sulfate. We look sulfate up on our list over here. Sulfate has a -2 charge. So then next we do the same thing for HCl and HNO3. So we'll start with HNO3 because NO3, nitrate, is found on our list. So we come over and look at nitrate, -1 charge. Next, we have chlorine. So chlorine is on our periodic table. So we look over here. Chlorine, when it becomes an ion, would gain 1 electron to look like argon, meaning it would have a -1 charge. So what you see here, guys, is that the acids, they still bind in a way so that they're neutral. So this first example over here, we need a +2 to balance out the -2 that's in our carbonate ion. Each hydrogen has a +1 charge, so we will need 2 hydrogens. So we need 2 H pluses to balance out the charge. The next example, the reason why we only have one hydrogen is because it only takes one hydrogen to balance out the charge, because it's a -1 charge. So in this one, we need one hydrogen to balance out the charge. So right now, guys, what I want you to think about question 13. So phosphoric acid is made up of phosphate ion and H plus ions. So what would be the formula for phosphoric acid? How many hydrogens would you need to balance out the charge of the phosphate ion? Well, like always, guys, if you have any questions, please circle them, write down your question, and bring them to class. That will still earn you credit. Like always, I try to end these with a joke. So why was the cat disqualified from the game? Because he was a cheetah. I hope everyone has a great day. I'll see you next class. Bye.